In the previous video, we covered the basic concepts of the design area. In this video, we'll explore additional NFPA 13 requirements and apply them through a series of practical examples. As we explored in the last example from the Basic Concepts video, based on the project dimensions and sprinkler layout, the design area should include 12 sprinklers, with 4 located on the most remote branch line. Now we'll examine the impact of the cross main on the design area. First, let's assume the cross main is shifted 20 feet to the north. In this case, one of the sprinklers on the most remote branch line is now located on the opposite side of the cross main. According to NFPA 13, this arrangement is permitted, so we continue with the same procedure to select the remaining sprinklers from the second and third most remote branch lines. Now let's assume the sprinklers are fed by 2 cross mains. As calculated earlier, we need to consider 4 sprinklers on the most remote branch line. The northern cross main supplies 3 sprinklers on each branch line, while the southern cross main supplies 2. This raises an important question. Can we include 1 sprinkler from the branch line fed by the southern cross main? The answer is no, we cannot. When a branch line doesn't contain enough sprinklers to meet the design area length requirement, the standard allows the design area to extend to adjacent branch lines, but only if they are supplied by the same cross main. Therefore, we select 3 sprinklers on the most remote branch line and 3 sprinklers on each of the second, third, and fourth branch lines to meet the minimum calculated number of 12 sprinklers and ultimately cover the 1,500 square feet required by NFPA 13. Up to now in the examples we've reviewed, the shape of the design area was a rectangle. However, in real-world projects, we often encounter situations where the design area is L-shaped, stepped, or even irregular. In this example, we'll see how to select sprinklers in such a layout to meet the requirements. As shown in this figure, the sprinklers are equally spaced in an ordinary hazard group 2 occupancy with S equals 10 and L equals 13 feet. After calculating the necessary parameters, we find that the design area includes 12 sprinklers, with 5 located on the most remote branch line. For the first and second most remote branch lines, we follow the same procedure as in the previous example, identifying 10 of the 12 required sprinklers. But for the third most remote branch line, where we only need 2 additional sprinklers to complete the design area, a question arises. Which 2 sprinklers on that branch line should be selected? In such cases, we must remember that the design area should represent the worst-case scenario for both pressure and flow in the sprinkler system. By selecting the most remote sprinkler, we satisfy the pressure criterion. To meet the flow rate criterion, we should select the remaining 2 sprinklers that are closer to the water supply, since water experiences less pressure loss along shorter paths. These sprinklers will have higher pressure and therefore discharge more water, helping us meet the required flow conditions. In the same example, if we simply change the location of the cross main, the shape of the design area will also change. This time, 2 sprinklers located on either side of the cross main are selected, since water experiences less pressure loss along these paths, resulting in higher pressure and greater discharge flow rates. Let's return to the previous example and review an important point. Since the sprinklers are evenly spaced and the distance from the most remote branch line to the wall is equal to half the spacing between sprinklers, the 12 selected sprinklers cover a total of 1,560 square feet on the floor, greater than the design area required by NFPA 13 and therefore acceptable. Now, if the sprinklers are shifted 3 feet to the left, does this change affect the design area? Since the coverage area of each sprinkler is determined using the S by L method, the total number of sprinklers in the design area remains unchanged. Additionally, because S is still 10 feet, the number of sprinklers on the most remote branch line also remains the same. The design area consists of a large rectangle and a smaller rectangle. The area of the large rectangle is 50 by 23 feet, which equals 1,150 square feet. The smaller rectangle measures 20 by 13 feet, giving an area of 260 square feet. Therefore, the total design area is 1,410 square feet, which is less than the 1,500 square feet required by NFPA 13, and thus not acceptable. In such cases, we need to add additional sprinklers to meet the requirements. In our example, by adding one sprinkler to the design area, we increase the coverage to 1,540 square feet, which exceeds the NFPA criterion and is therefore acceptable. This example shows that even slight shifts in sprinkler layout can impact the design area. Therefore, accurately calculating its size to ensure compliance with requirements is essential. When the spacing of sprinklers along the branch line is not uniform, we cannot simply divide the length of the design area by S to determine the number of sprinklers on the most remote branch line. In these cases, we need to follow a different method, which we'll review through an example. Assume a light hazard occupancy where the required design area is 1,500 square feet, and the sprinklers are non-uniformly spaced as shown in this figure. As the first step, we calculate the length of the design area using the same formula we reviewed earlier. Then, we draw a line with the calculated length starting from the wall behind the most remote sprinkler and extending parallel to the branch line. All sprinklers within this line, numbered 1 to 4, shall be included in the design area. However, whether sprinkler 5 should be included depends on the S of sprinkler 4. If the S fully covers the length of the design area, sprinkler 5 is excluded. Otherwise, if the S falls short, sprinkler 5 must be included to meet the required design area length. In this example, the S of sprinkler 4 is 12 feet, meaning it covers 6 feet above and 6 feet below along the branch line. Since sprinkler 4 fully covers the remaining length of the design area, there is no need to include sprinkler 5. Let's review a condition where sprinkler 5 must be included in the design area. Assume the distance between sprinklers 2 and 3 decreases to 11 feet. In this case, the S of sprinkler 4 is no longer sufficient to cover the full length of the design area. As a result, sprinkler 5 must be added to ensure the design area meets the requirements. It's important to note that after identifying the sprinklers on the most remote branch line, we must calculate the final length of the design area. This is done by summing the distance from the wall to the most remote sprinkler, the distance between sprinklers, and half the S of the last sprinkler. Since the S of the last sprinkler is 13 feet, half of that is 6.5 feet. Therefore, the final length of the design area is 56.5 feet. There are several methods for determining the total number of sprinklers in a design area. In this video, we'll review a simple and practical approach referenced in the handbook of NFPA 13. This method is based on the halfway point principle, where sprinklers are added until the required design area coverage is achieved. In this approach, each sprinkler is assumed to cover the area extending to the halfway point between itself and adjacent sprinklers, both along the branch line and perpendicular to it. In the previous example, we calculated both the final length of the design area and the number of sprinklers on the most remote branch line. Based on the halfway point approach, these sprinklers extend coverage halfway toward the second most remote branch line. Since the distance between the two branch lines is 12 feet, the coverage area of these sprinklers extends 6 feet to the east. For sprinklers located adjacent to a wall, we assume they cover up to the wall itself. Therefore, The sprinklers on the most remote branch line also cover 5 feet to the west, completing their contribution to the design area. The length of the area covered by the 5 sprinklers on the most remote branch line is 56.5 feet, and the width is 11 feet. Therefore, these sprinklers cover a total of 621.5 square feet. Since the required design area is 1,500 square feet, we need to add more sprinklers to meet the NFPA 13 requirement. We now include sprinkler number 11, which is closer to the water supply in the design area. Using the halfway point approach, this sprinkler contributes an area of 11 by 12.5 feet, totaling 137.5 square feet. We continue this process, adding sprinklers and calculating their contribution until the total design area reaches at least 1,500 square feet. By selecting 12 sprinklers, the design area reaches 1,525 square feet, which is greater than the minimum required by NFPA 13 and therefore acceptable. As mentioned earlier, when sprinklers are non-uniformly spaced, there are alternative methods for calculating the number of sprinklers in a design area. For example, in the method introduced by NFSA in Chapter 29 of the Layout Book, 3rd edition, the number of sprinklers in the design area is determined using the S and L rather than the halfway point method. This technique aligns more closely with the S times L rule. Since these methods may yield different results, it is essential to consult with the authority having jurisdiction to ensure compliance and obtain approval.